Statistics. Statistics is a chapter often ignored by students, but it have really vast majority of weightage when it comes to UPSC NDA exam. There are a lot of questions asked from this chapter, and the only tough thing about this chapter is its calculation. Just if you are good at numbers and good with numbers, and you are a person who can focus your entire awareness into the calculation, then it's a very easy chapter. Just have to apply the formula and get the answer, and not just one or two questions. There will be multiple questions from this chapter, around five, more than five even, and five will be very easy. So, statistics. Statistics is the study of data, and data which is coming out of observations. And we run some operations on the data so that we can analyze and observe the data. Okay, talking of which, let's start our statistics chapter with data. So data can be given in two forms. There can be group data available to with us or ungrouped data. First, let's talk about group data. Let's say there is a class. Let's take a typical example of a class in which here I am the class mark or the class interval, which I call like we are talking about a subject, let's say mathematics. Students who have scored between the total score for the examination was the maximum marks was 40. So student who have achieved from 0 to 5 marks, and here I'll write the frequency. How many students have got these marks, and I'll represent this as f of I. So the number of students who have scored marks between 0 to 5, excluding 5, is 2. Let's say, just for an example, let's say it is 2. Students who have gained marks from 5 to 10, this time 5 is included and 10 is excluded, is 2. Say then 10 to 15, 0 students have got these marks, 15 to 20. One student, first let me write 20 to 25, then we will discuss about 25 to 30. Let me make some space. Thirty to 35 or 35 to 40. Let us, let's say 20 to 25 marks have been scored by 0. 25 to 30 marks has also been scored by 0 students. And 30 to 35 marks has been scored by 1 student. And there is also one more student who has scored marks between 35 and 40, not 45. Okay. So now you can see this that we are calling as class interval has same difference, like 0 to 5. There's a difference of 5, difference of 5, difference of 5, difference of 5, difference of 5. So that's one prerequisite that we require for studying the data. Okay. Now there is also frequency given. Frequency is telling us that uh, number of samples or number of people that have scored that much that are lying in that class. Like this is the first class, second class, third class. We have divided the students in different classes, and we have uh, jotted down that how many students lie in which class. Okay, this particular spread of data is known as group data. Okay, group data, where 0 is included, where the first, this is known as a typically class. Okay, in this class, this is known as the lower limit, and the 5 is the upper limit here. So the upper limit is excluded. The lower limit is included. Let's now talk about ungrouped data. So the data which is just given to us, like just given, that let's say we are talking about a number of birds or number of vehicles passing on a highway from a particular point. So let's say I've counted two going in a cluster, then three going, then five, then nine, maybe then 15, then 32 or 35. Okay, this also, like, the data can be anything. So if data is spread, data is ungrouped, then it will be called as ungrouped data. Simple. It is what we have. No xi, no fi. And what is xi? We call class intervals average as xi. If I have to write xi here, so I'll write 0 plus 5 by 2, that is 2.5. 5 plus 10 by 2, that is 7.5. 10 plus 15 by 2, that is 12.5. Then 17.5. And then 23.5, I'm guessing. Yes, 23.5, 28.5, 33.5, and then 38.5. So what we have done for finding out xi, lower limit plus upper limit divided by 2. This is known as the class mark. This is what we have talked about ungrouped data. Now, this particular form of group data have two manifestations, two parts, two representations. This one particularly that we have talked about is exclusive form of data, exclusive group data. Exclusive group data. Let's now talk about inclusive grouped data. So this time, earlier, like, let me draw exclusive group data here for an example. So in exclusive group data, the class interval was such that 0 to 10, then 10 to 20, let's say 20 to 30, 30 to 40. But in inclusive group data, the class interval will be such 0 to 10, then 11 to 20, then 21 to 30, then 31 to 40. This time, earlier what was happening? Earlier, this was exclusive. This was exclusive. We were not including this in this class. So 10 was not included, 10 was excluded. Here, 10, 20, 30, 40, this and as well as this, these both are included. Earlier only the lower limit was included. This time, the lower limit as well as the upper limit, they both are included. Both are included. They both are included. This is the difference between inclusive group data and exclusive group data. Okay. Why are we differentiating them? We are differentiating them because this is very important, because no operations of statistics, I'm writing stats, the short form, could be applied on discontinuous or inclusive group data. No operation can be applied on this. This is also known as discontinuous group data. And this is known as continuous group data. Okay. If that is so, what if we have only inclusive group data given with us? Then what should we do then? Let's say it is given in the question, the class interval is. So what we are doing is discussing about that we are conversion of discontinuous to continuous group data. If the given class interval is like 0 to 10, 11 to 20, 21 to 30, 31 to 40, then what will you do? So we'll simply do one trick, is that we have to bridge the difference between these two now. We have to bridge the distance between these two. So we'll find out the delta. Delta will be same everywhere, which is 11 minus 10, 1. So 1 is the difference. So what we'll do, we'll divide it by 2 and we'll plus and minus. We will add the delta by 2 to the what should I say, upper limit. Okay, we will add the deltas to the upper limit and we will subtract delta by 2 in the lower limit. I know this is confusing. Let me do it. So here we have observed that the delta is of 1. Delta 1, we have seen here that the delta is 1 and delta by 2 will be 1 by 2, which is 0.5. So what I'm going to do is I'm going to add 0.5 here. Now I'm going to subtract 0.5 here. Now I'm going to add 0.5 in the upper limit. Okay. So 0 minus 0.5 is actually minus 0.5, which do not exist. So we'll write 0 only. 10 plus 0.5 becomes 10.5. We'll subtract 0.5 from 11. So 11 minus 0.5 is 10.5 only. 20 plus 0.5, 20.5. 21 minus 0.5, 20.5. 30 plus 0.5, 30.5. 31 minus 0.5, 30.5. 40 plus 0.5, 40, which cannot be the possibility because the maximum marks of the mathematics paper was 40 only. Right, 40 only. So this is how we have made the class interval a continuous group data. Okay, great. So this is about different forms of data. We have already talked about class mark concept. Let me rewrite the formula. Class mark, also denoted by x of y, will be lower limit of the class plus upper limit of the class divided by the right, divided by 2. That is the class mark. Okay, so let's move forward without wasting any time. And now what we are going to discuss is measures of central tendency. So actually we have lots of data, and we are going to analyze the data, and we analyze using certain tools and using certain perspectives, opinions. So first way to look at data is to measure its central tendency. So I'm calling it a measure, or it's been called as measures in the textbooks. So measures of central tendency of data, where we talk about the central tendency of any data. Like for example, in physics we have studied center of mass concept, right? Where we discuss that where the mass is concentrated and where is the center line for the body. So similarly, on certain same lines, we will be discussing these measures of central tendency of the data. So what are the tools? This is the measure, this is the perspective. What are the tools to discuss it? First one is to discuss its mean, which is also known as average in our layman terms. But in bookish language, it is the mean. Okay, and mean also we can find the mean in with three by like looking at data from three perspectives. One is to look at the data from arithmetics, which is more of like plus minus, or geometric mean. Where were you, Yarini?
Good afternoon, sir.
First is that we can find the mean of given data, and mean can also be find it out by different uh, taking different factors into consideration. If we look at plus minus operations like sum, then we discuss about, we call it as arithmetic mean. When we discuss about the multiple or division factor, then we call it as geometric mean or harmonic mean. When we discuss about oscillatory changes in data, then we call it as harmonic mean. So there are three different kinds of mean: arithmetic mean, geometric mean, harmonic mean. The second measure for central tendency is median, where we find median of the data. What's the median? What is the medium point? We also discuss mode of data. Mode means the observation which is most repeated, which is like the maximum number of time it's repeated. Let's say there are that there are five observations, and out of these five, there's a particular observation repeating itself three times, and no other observation is repeating that many number of times. So that becomes the mode. The single observation becomes the mode. So these are some measures for central tendency. We are going to discuss them one by one. Okay. So shall we move ahead? First, we'll discuss about mean. Let's talk about arithmetic mean, which is mostly what we refer to mean only. Na? If in questions it is only given that the mean of the observation, so they are referring to arithmetic mean only, which is founded by, and first let's talk about its denotation. X bar represents the mean of X observations. So it is given by sum of all the observations divided by the number of observations. So we know that data can be given as in two forms, ungrouped data or group data. First, let's talk about ungrouped data. Let's say data is given in the form of x1, x2, and this like this. There are n terms given. So to find out its mean, we'll simply do one thing. We'll take the sum of all the x terms starting from 1 to n. We'll divide it by the total number of observations. x1 plus x2 plus x3 plus x4 and then 2 and the xn divided by. Any doubts?
No, sir.
Okay, let's take an example. Let's take my example. Let's say there are 7 days in the week, and on the Sunday I run 10, then I run 5, then I don't run anything, then I again run 3, then 5. How many? Then nothing, and then again 5. No, this is not real. I just made it up. But somewhat it is like this only. So these are 7 observations. If I have to find my average running distance, so it will be given by the sum of all 10 plus 5 plus 0 plus 3 plus 5 plus 0 plus 5 divided by the number of observations, that is 7. Okay. 15, 20, 25, 28 divided by 7. 4 kilometers. 4 is the average. 4 is the average distance. Okay, let's now talk about group data. If group data will be given, then the formula for mean is we have to find the sum, but we also take consideration that how many times the data is getting repeated or how many times it is existing. Like a class is having how much weight, how much frequency in it, divided by the total number of observations, which is also sigma or fi. This is very important thing to understand. Just not uh, cram it or memorize it sigma of fi. Okay, there's something fi. This is actually frequency. When we are talking about this data, it means that two students have scored marks like 0 to 5 marks and are classified as class 1. That is what the first column is, the first class is saying. The second class is saying that other two more students had scored 5 to 10 marks and are classified as in class 2. No student has scored 10 to 15 marks. So this is what the table is saying. So actually, how many observations do we have? 2 observations here, 2 more here, 0 here, 1 here, 1 here. So if I add them all, then 2, 2, 4, 5, and then again 2. 7, total observation are 7, which is actually sigma of f. Now you will not ever get confused if you have understood this. Sigma of fi is the total number of observations that we have. Is this clear?
Yes, sir.
Sigma of xi multiplied with fi, then it's summation divided by total number of observations. That is sigma of fi. This is the formula of data, where xi is the class mark, this is the mean, this is the frequency, and this is also the frequency, and this is the class mark. Upper limit plus lower limit divided by 2. So this is first method known as the direct method. Direct method to find out the mean. And this is more than sufficient to use in the NDA paper. But don't have to memorize other two methods. But as we are in a class, so we'll discuss them. But don't have to memorize them. Like for the exam. But yes, of course, it's important for the board. Second method to find out the mean in group data is assumed mean method. Where you assume nxi as mean, denoting it by a or small a. Okay, and then the mean will be given by assumed mean plus fi into di divided by fi. What is di here? Di is not the class mark, it's the deviation. It's the deviation. Deviation from what? Deviation from a. So instead of xi, you'll find out xi minus a to find out the deviation. Okay, so let's take an example. Let's take an example. So in the question, the class interval is given 0 to 10, and then 10 to 20, 20 to 30, 30 to 40, 40 to 50. Yes, this much only. And fi is given. These two things will be given to you. 8, 10, 6. How much is this? This is 6 only. 6 and 12 and 4. This is the question. You have to find the mean. Okay. So we have to find the mean. What we need to find out? We need to find out the xi for sure. We need to find out the sigma of fi, which is the sum of all. So the sum of all is what? 8 plus 10, 18, 18, 6, 24, 24, and then 16 makes it as 40. Xi. 0 plus 10 divided by 2, 5. 0 plus 10 divided by 2, 15. And 20 plus 30 divided by 2, 25. And 35 and then 45. We have got the gist. This is the sigma. This is the xi. If we have to find out using direct method, if we have to find the mean using direct method, we'll find out fi xi. for every class. We'll multiply these. 8 into 5, 40. 10 into 5, 15, 150. 6 into 25, 150 also, I am guessing, yes. 12 into 35, 12 5 just 60, 6 carries, 12 3 is 36, 36 6 42, 4 into 45, 90, 180. Okay. We also have to find out the summation of fi xi. Xi fi or fi xi. This is commutative, no problem. So 0 0 0 0, 4 5 9 9 5 14, 14 and 10, 24, 2 carries, 2 2 4 4 4 8 8 and 9 940. So the mean be sigma xi fi divided by sigma fi. Sigma xi fi is 940. Sigma fi is 40. 0 0 cancels. What is 94 by 4? Come on, answer. What is 94 by 4? Yarini.
Sir, it's 23.5, sir.
Sorry?
23.5, sir.
23.5. Yes. I hope you have calculated by yourself. So this is the mean, 23.5 using the direct method. It's very easy also. But if we don't want to take a lot of load of multiplying and then calculating this, we'll go by the assumed mean method. We'll assume one xi to be its mean, and we will assume conveniently the number which is in middle. So I'm assuming 25 as my mean because it's in the middle. Okay. Now what we have to find out for assumed mean method? Assumed mean method, A plus sigma of di into fi or fi di, sigma fi. So sigma fi is found, fi di. So first let me find out the di. Di is actually xi minus of a, which is actually 25. Okay, nice. So 5 minus 25 is actually minus 20. 15 minus 25 is minus 10. 25 minus 25 is 0. 35 minus 25 is 10. And this is 20. This is 20. The sum of all the di's will always be 0. But we are not worried about the sum of di. What we have to find out is the sum of fi into di. The sum of fi into di. So let me write fi di here. We will multiply 8 into minus 20, that is minus of 160, 10 into minus of 10, minus of 100, 6 into 0, 0, 12 into 10, 120, 40 into 20 as 80. We'll sum them up. Sigma fi di. Minus 160 minus 100 minus 260, minus 260, 120 plus 80, that is plus 200. So this comes out as minus of 60. So the mean now becomes, assumed was 25 plus sigma of fi di is minus 60, sigma of fi is 40. So this is 25 minus 6 by 4, which is actually 3 by 2, which is 1.5. 25 minus 1.5 is what? Yes, please respond. What is 25 minus 1.5?
23.5, sir.
Yes, 23.5, which is our answer. This is how we can use different mean methods to find out mean. Okay. So this is about mean. Let's now discuss about some properties of mean. So there are two changes that can occur to our data. There are two types of changes which can occur to our data. And please understand this very carefully. One change can be of scale. Let's take an example of Google Maps. When we pan out the world map, then every centimeter or every measures different kilometers, maybe hundreds or thousands of kilometers. No, sorry, hundreds of kilometers. And when we pan in, then the value decreases and decreasing. It's like, let's say, if I write 5, this is my data. If I write 5 centimeter or 5 meter, this is actually the same data, but with different scales. Scales is different. This time this is 500 centimeter and this is 5 centimeter. The scales are different. Here the scales are different. Here the data is different. Okay. So whenever we multiply or divide to adjust the scales, है ना? To adjust the scales, what we do? We multiply or divide. That's what we do to adjust our scales. 5 meter to 5 centimeter, 5 meter to centimeters. So that's 500 centimeter. So we have multiplied by 100. So when there is a change of scale, so there is a multiplication or division. Okay, multiplication or division. And there's another kind of change, change of origin. What we discuss in Galileo transformation. You will study this in BSc. Otherwise, in class 11 physics as well, we study about the frame of reference. When we shift the frame of reference from the moving object or to the object that is stationary on the ground, so there is a change in origin, and that we shift by adding or subtracting. Let's say this is one Cartesian system, and this is another Cartesian system I'm drawing with green. So here the delta, we change the origin by O plus delta from yellow to green, or from green to yellow by O minus delta, right? So here we add or subtract simply to discuss the change of origins. We add or subtract. Okay. So these are the two kinds of changes that can occur to our data. But when we are discussing about data, so this change will not occur to a single data. This change will occur to all the datas from all of the observations. Let me say if there is observation x1, x2, x3, x3 dot 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 xn. These are all the observations. So if I'm saying there is a change of scale by, let's say, if I'm multiplying something by p, then the new data which will be formed, that will be px1, px2. These are all the observations that have changed due to the change of scale to pxn. So that's how change of scale happens. Not to a single observation, but to all. And there can be division also. There can be division also. When it occurs with like x1, x2, x3, xn, there are xn data. If there is plus or minus with p, then the new observations become x1 plus minus p, or x2 plus p or minus. Similarly, xn plus p or minus if it is happening. So these are the two changes of scale that happens to our observations. But they do not happen to a single observation, it happens to overall. Is this thing clear?
Yes, sir.
Okay. So now we will discuss that how change of scale or change of origin changes our mean or how it affects our mean. So mean depends on both change of scale and change of origin. It depends on both the mean. How? Now question comes how. It depends. Give me a minute. The mean depends on both change of scale and as well as change of origin. Now questions come how. Okay. So this time I'm not going to write x1, x2, xn. I'm just going to represent all of the observation by xi. So whenever there is something added in the observation, in all of the observation, then the mean, the new mean. So when all the observations are added with p, then the new mean becomes also gets added with p. If all of the observation gets subtracted with p, then the mean also gets subtracted with p. If all of the observation gets if all of the observation gets multiplied with p, then the new mean also gets multiplied with p. If all of the observations gets divided by p, then the new mean also gets divided by p. As simple as that. Very easy to understand. Are there any questions?
No, sir.
Let's take an example. So here is a question. Let for some constant a and c. Then what will be the mean of y1, y2, and yn? This is what we need to find out. Options are a plus c, option number b, x bar representing the mean. Option number B, a minus of x bar by c. Option number C, a, sorry, x bar by c minus of a. Option number D, x bar minus of a divided by c. So this is the question. So we have everything. We have the observations and their mean. And it is also given that xi is a plus c yy. Yy is the every element of y, and xi is also same element of y. Like x1 is equals to a plus c y1, or x2 is equals to a plus c y2. This is how. So we need to find out the mean for y, na? So first let's find out the every element of y using the relation. So from here, what we can write, xi minus of a divided by c is yi. Like this is the every element of c. And we know when every element is getting subtracted, then its mean will also get subtracted. And when every element is also getting multiplied by c, then its mean will also get multiplied by c. So the new mean for y becomes x bar minus a divided by c. Option number D is the correct. Because even the plus minus matters, and as well as the multiplication or division matters for us. So we have considered both of the factors. Is this clear? Okay, let me explain it using giving the long explanation. So every element of xi is this. What we have, sigma of xi. Sigma of xi divided by n is x bar, where n is the number of observation for x. ठीक है? What is xi? A plus c y I divided by n. This is x. What is the sigma of a for n times? Sigma we are considering for n times now. If we add a n times, then it becomes na. Okay, plus sigma of c yi and divided by n x bar. So na by n becomes a. Now c will come outside. C will come outside, it can be taken common. Okay. C sigma of yi divided by n is equals to x bar. Okay, fine, fine. Now, actually, this was NA, na? This was NA. So when we segregate, when we differentiate and we write like this, we write like this. So NN cancels. A plus C. What is this? The sum of y observation divided by n is the mean of y. Is equals to x bar. So y bar c, taking a onto the right hand side, x minus a. Now c onto the right hand side. Our answer. This is by doing it using a longer method. But if we know the property, we directly solve it now. Is this clear now? Any doubts? Yadini?
No, sir.
No doubts. Okay. Let's now discuss about combined mean now. Okay. Combined mean. Combined for what? If we have two set of observation or more than two set of observation, and then we find the combined mean, that is when we have to discuss about it. So let's say if I have two set of observations like x1, x2, x3. This is the first set of observation. The another set of observation is, let's take y1, y2, y3, y. The mean for the x is given as x bar, and the mean for the y is given x y bar. Also, let's take the different, let's take the number of observation as also different. Like the number of observation in x is 1 n1, the number of observation in y is as n2. Okay, the mean is given. So we know mean can be find it out by we are actually we are adding them all. We are adding all of the x till n1, dividing it by n. For the mean of y, we are adding all of the y's till n2 from 1 and dividing it by n2. What we need to find out right now is that we are combining both of these observations. These are set 1 of observation and set 2 of observation. We are combining them. We are making a union set. Actually, not the union set, we are just combining them. So now we have to find the observation of the combined set. How do we have combined them? We have taken all of the observations from set A and then have copy paste. Taken all of the observations from set A, and we have also taken all of the observation from set B. And now we have to find out its mean. Okay, its mean will be given by the sum of all. By the sum of all. Okay, let's try. Let's bring this onto the next page. So its mean will be given by sum of all divided by the number of observation. The combined mean. How should I write it? Combined mean is given by the set, by the sum of all. So the sum of all x observations till n1 and the sum of all observations of y I n2. These are the sum divided by the total number of observations. N1 are these of x set and n2 are of these y set. So the total observations are n1 and n2. Okay. Now we need to find out is what? The sum. From here, we can find out the sum. So mean into n1 is actually the sum of all x observations. And similarly, it's the same with the number of observations into the mean. It will give us the sum of all observations. Okay. So this is n1 into its mean plus n2 into its mean divided by n1 plus n. So this is how the formula is derived. And even if we have more number of observations, we'll apply the same method. So this is how combined mean is solved. You don't have to memorize this formula. I'm going to write different formula. So is the concept clear that how have I find it out the mean combined mean?
Yes, sir.
Okay. So the formula to remember is if you have two set of observations, say as x1 set and x2 set. So the combined mean will be given like this, and we'll multiply the number of observation with the mean of the first set of observation. We'll multiply the number of observations of set 2 with the mean of the observation of set 2 divided by the total number of observations. That is a combined mean. Now, what if we have more number of observation that we are combining? Say we have total like a number of observations, a number of observations. Okay, so we'll do the same till for all of the observations. We have total A observations, and we'll multiply the total upon the total number of observations for all. So this is the formula of combined mean. Let's take an example. Okay. There is a class. Give me a minute. Okay. So what is given to us is that there is a class of 30 girls which have in which in a class there are 30 girls. So there are 30 girls. They have an average of 85. We call the number of observations as 30. And there are 20 boys. 20 boys which have an average of 90. Oh, this time the boys are better. Nice. Okay. So the combined mean, as we know, is given by n1 into x1 plus n2 to x2 bar divided by n1 plus n2. N1 is 30 into 85. That gives us the sum 20 into 90 divided by 30 plus 20, that is 50. So we can also, for making our easy calculation easy, let's cut the zeros from everywhere. 85 into 3 is what? 255. 20 into 90 is what? 20 into 9 is what? 180 divided by 5. This is 5 1. This is 3 6. 5 1 plus 3 6 is 87. This is the average mark of a student in the class of 50. Clear? Any doubts?
No, sir.
Okay. Next question is the average age of a combined group of men and women. Its average age is 25 years. And what is given? If average age of men is 26 years. Is 26 years. And that of group of women is 21 years. We have to find the percentage of men and women in the group. We have to find the percentage of men and women in the group. That is our question statement. Okay. So we know this is average age, this is the combined mean, actually. This is the combined mean. So if we have combined mean, we have the average age of the first group, average age the other group. What we don't have is the number of people, number of people. So we'll do simply, we'll consider that there are, let m number of men are there, and let w number of women are there. Okay. 25 average will be given by the number of men into their average age plus the number of women into their average age is 21, no? Yes. Divide by total number of observation, that is m number of persons plus w number of women. So what we need to find out is the percentage of men and women. Okay, we'll find out because we don't have to find the exact value. Neither we are able to do so when there are only two coordinates on a single equation. We can only find the ratio. Let's move ahead. 25m plus 25w on cross multiplying. 26m plus 21w. Let's bring the w's on to the right hand side. 25w plus minus 21w. And m's on the right hand side. 26m minus 25m. So this makes sense 4w equals to 5m. So the ratio of men to women is 4/5. Men to women is 4/5. There are four women and five men. There are 4 men and 5 women. Okay. So there are 4 men and 5 women. How do we find out the percentage? So 4 women and 5 men. So let's say simply यार ये दिख रहे हैं इसमें कि there are less men and 5 women. So the ratio will be around, let's find it technically. Otherwise it will be around 80/20, I am guessing. So men is 4w divided by 5. This is the number of men. So for finding out the percentage of men total, so we'll find out the number of men, which is 4w upon 5 upon total. So total is m plus w na? Okay, dividing it by 100. So this will be 5, 20, 80w divided by m plus w. What is the percentage of women? Women are 5m by, so first let's calculate it completely. So 80w divided by m plus w. So m is 4w by 5 plus w. So 80w, we'll take the LCM, 4w plus 5w, 9w into 5. W cancels, 9 cancels 80 by, no, 9 does not cancels 80. So 18 to 5, 18 to 5 is 8 5 is 400 by 9 percentage of men are there. 400 by 9 percentage of men are there. How many percent of women? So how many percent of women is that W upon, actually Let me redo it. It's a lot of mess. See, what we need to find out is the percentage of men and women. Percentage of men will be given by the number of men upon number of men plus number of women into 100. Percentage of women will be given by number of women divided by the number of men and the women into 100. So from here, what we'll find out m plus w. So what is from here we can find out the number of men is 4w by 5. Okay, so m plus w becomes in single variable. So m is 4w by 5 plus w. So m plus w becomes 4w plus 5w, that is 9w by 5. Okay. So the percentage of, we have this in the terms of W. So let's find out the number of men in terms of W only. So the number of men is 4W by 5 into 100. And the number of M plus W is 9W into 5. W cancels, 5 cancels. This becomes 400 by 9%. Okay. Coming to here, m plus w is in terms of w, so we'll keep it in w only. M plus w is 9w on 5 into 100 as well. W cancels. This becomes 500 by 9%. So this is the number of percentage of men and women in the group. So this is the number of percentage of men and women in the group. This is not in the comparison of each other. Okay. This is the comparison, like when we find out the percentage, na? So we are finding out with the respect of total number of men and women here. So this is our answer. If we have to find out the percentage of men with respect to women, then number of men upon number of women into 100. This was the ratio. Okay. So if that is so, but this is not we have to find out. I'm just giving an example. So m by w is 4 by 5 into 100. This cancels by 20. This becomes 80. So 80% of women, like 80% of the number of women are the men. This is the analogy. By the way, this is not asked. What is asked is this percentage of men and women, which will be given by this. Clear?
Yes, sir.
Please, अगर यहाँ पर and नहीं होता ना, if there were two written instead of and, then we'll find out m by w into 100. Number of men to women percentage. And if there is n written, so we'll find out m upon w plus m into 100, because now we are talking about a whole group. Clear?
Yes, sir.
Let's now discuss about the next mean, that is geometric mean, that we have also discussed in sequence and series chapter. So if there are like observations and observations, so the geometric mean will be the multiplication of all x1 multiplied with x2 multiplied with, I should write dot instead of these, x1 dot x2 dot x3 xn, and its power will be raised to 1 by n. That's basically the geometric mean. Is simple. So for example, if we have 2, 4, 8, 16, 32, and we have to find out its geometric mean, it will be given by its multiply raised to power. How many observations are these? 5. This is how we find it. So we know all of these can be written in the form of 2 raised power something. So this can be written as 2 raised power 1, 2 raised power 2, 2 raised power 3, 2 raised power 4, 2 raised power 5. So the base is same, x power will get added. So 2 raised power 1 plus 2 plus 1 plus 2 plus 3 plus 4 plus 5. Sum of natural numbers n into n by n into n plus 1 divided by 2. So this will become 5 into 4 by 2, 5 into 2, 10. No. 5 into 6 by 2. 5 into 6 by 2 is 3. 5 into 3, 15. It will become 15. 2 raised to power 15 into 1 by 5. 5 cancels 15 by 3. So 2 raised to power 3 is the geometric mean, which is actually 8. Which is actually this. No, but I'm not saying that this middle term will always be the geometric mean, but it is here in the special case. We'll find out the geometric mean using this formula. Is this clear?
Yes, sir.
We can also find out the harmonic mean. These are not important when it comes to statistics, but important when it comes to sequence and series. So basically, if there are observations x1, x2, and xn, the harmonic mean will be number of observations upon the sum of all of the reciprocals. This is basically how we can find out the harmonic. Clear? Should I give an example? 2, 3, 6. The harmonic mean, number of observation upon 1 by 2 plus 1 by 3 plus 1 by 6. 3 upon the LCM is 6. 2 into 3, 3 into 2 is 6, 6 into 1 is 6. 3 into 6 divided by 2, 3 plus 2 plus 1, that is 6, 6, 6 cancels 3 is the harmonic mean. Clear? Please don't have a misconception that the middle term is only the harmonic mean or the geometric mean. No, actually these are some special examples. So it is happening here only, not always. Clear?
Yes, sir.
Yeah. Give me. So let's take a 3-minute break or a 4-minute break. Okay. So median we'll find out. Then we'll discuss the next measure of central tradition. Next measure of central tendency, which is median. So first, let's discuss about if we are given with ungrouped data, then how can we can find out the median. So if let's say there are n number of observation, first in the case n being an odd number of observation. So if there are the odd number of observation, let's say if I write 2, 3, 4, 5, 6. So these are 5 observations. So these are the number of observation is odd. So we can evenly leave out the remaining. The middle term will be our median. Let's say if 2, 3, 4, 5, these only 4 observations are given. Now there is no middle term. So in this case, we will we will take the middle 2 terms and we'll leave the other one. Okay. And then we'll sum them and divide them by 2, which will be our median 3.5 and 4 here. So this is what we are going to do. Let's write it in the form of formula. Okay. If there are n number of, if there are odd number of observations, then what we will do, we'll simply take the n plus 1 by 2th term. This will be our median. If n is odd, if there are odd, if there are even number of observation, then n plus 2th term plus n by 2th, n by 2 plus first term, the term just next to it, we'll take the sum and divide it by 2. This will be our median this time. We have discussed about the example already. Clear? This is
Yes.
how median is given. So let's now take an example of group data. So in group data, when group data will be given to us, then we'll have to find out we'll have to find out a certain column known as CF, which stands for cumulative frequency. First, learn the formula, and then you will better understand the use after we take an example. L1, which is the lower limit of the median class, into L2 minus L1 divided by the frequency of the median class, further divided by n, by the total number of observations divided by 2 minus CF of the class above to the median class. So let me write what is what here. L1 is the lower class, lower limit of median class. Median class, I'm giving it a funny acronym. And L2 being the upper limit of median class. F is the frequency, is the Fi, simple. F is the frequency of median class. And N is the total number of observations. And what is left? CF is the cumulative frequency of the median class, of above median class. How should I write it? Of the class CF of the immediate above class to the median class. Okay, let's take an example. Say the class interval is 0 to 10, 10 to 20, then 20 to 30, 30 to 40, 40 to 50. The frequency is 6, 7, 10, 9, and 8. This is the frequency of occurrence. This is what given to us. We'll find out CF. Okay. How do we find out the CF? First, we will exactly write the frequency here. Then we'll add this and this, 6 and 7, 13. Then we'll add 13 with 10. It becomes 23. Then we'll add 23 and 9. That becomes 32. We'll add 32 and 8. It becomes 40. This is the cumulative frequency. And this is the way we find it. We have finded out the CF by writing this here and then adding, then adding, then adding, and adding. Is this clear? How do we find out the cumulative frequency? Yes or no?
Yes, sir.
And if you have finded out it correctly, this last is n, which is sigma of Fi, like the sum of all. If we sum it all, na, then it is 40 for sure. Let's check. 8, 9, 17, 17, 10, 27, 27, 7, 34, 34 and 6, 40. Yes, it is so. Okay. Now, how do we identify the median class? So the median class will be identified by taking the half of n. We'll take the half of n, which is 40 by 2, 20. So now we will look at the CF from above and will find where 20 is included. Is 20 included in 6? Yes or no? Is 20 included in 6? No. 20 is more than 6 is less than 20. Is 20 available in 13? No. Is 20 available in 23 wali class? Yes. 20 is less than CF. So this becomes our median class. This become our median class. This might help. Find the cumulative frequency for each class and locate the class that contains a middle value. Middle value being n by 2. Middle value is n by. So we have find it out the middle class. What is the lower limit of middle class? 20. What is the upper limit? 30. What is the frequency? That is 10. What is the CF? Not 23. We'll see the CF of above class, which is 30. Okay. And was there something else also? N by 2 minus CF. No, this is much. This is only. So let's find out the median. Median will be median L1 plus N plus L. Array R. Yes. L1 plus the class difference L2 minus L1 by F into N by 2 minus CF. Okay. L1 is 20 plus L2 minus L1 is 10. Frequency is 10 into N by 2, which is 20, minus of CF, which is 30. 10, 10 cancels, 20 cancels. So, no, 20 here, but it does not cancel. Why 20 will cancel? 20 plus 20 minus 13, that is 7. So 27 becomes our median. Clear? 27 is our median, which is lying in the median class interval 20 to 30. So 27 is the median. Clear?
Yes, sir.
Yes. Okay. We have very good question here. Let's discuss it. A sample of 5 observations has mean 32 and median as 33. Later, it was found that the observation was recorded incorrectly as 40 instead of 35. It was if we correct the data, which one of the following is the mean and median? So the options are A, mean and median both remains the same. Option B is mean and median both decreases, and option C is mean decreases, median remains the same. Option D is median decreases and mean remains the same. That is the question. Okay. There are 5 observations. Okay. Tuck, 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 tuck. Its median is 33 and mean is 32. We know if there are like 5 observation, odd number of observation. So this middle term will be our median. So this term is 33. It is sure. Now the median is given as 32. Okay. Now we are talking only about this case. Na? So let me call this term as A1, A2, and A4 and A5. So the sum of all 33 plus A4 plus A5 divided by 5 is equals to 32. So it gives us A1 plus A2 plus A4 plus A5 is equals to 32 into 5, which is 160 minus of 33. So the sum of all 4 terms becomes 160 minus 33, which is actually 127. I'm guessing it. 127. Yes, it is correct. Okay. Now, later it was found that the observation recorded was incorrectly as recorded as 40 was 35 actually. So actually there was 40 recorded, but it was actually 35. So 40 can be here or here, but 40 can, like, when we find out the median now, first, yes, this important point I have missed adding it. I'm very sorry for this. When we find out the ungrouped data median, first step, which is very important, is to arrange all terms in ascending order. And then is the second step to find out using this. Okay. So when we have find it out this median of all these 5 terms, A1 is less than A2, A2 is less than 33, 33 is less than A4, and A4 is less than A5. So if there was 40, then it is definitely, it should be definitely situated at A4 or A5. Okay. So if 40 becomes 35, let's say A1, A2, 33, A4, and A5. If here instead of 40 it becomes 35, the median will remain the same. Because the third position is occupied already. So it is for sure that a median remains the same. Now, what about mean? See, we don't have to find the exact value for the mean. We just want to have an idea. When 40 will decreased by 5 and will become 35, so the overall sum will be also decreased by 5. Okay. So somewhere we can say that the mean will also be decreased. The mean will also be decreased because the sum will be decreased by 5 divided by 5. Total number of observation are 5. I am representing sigma as the sum of all observation. Why minus 5? Because 40 will become 35. Lessen. Okay, the sum will lessen by 5. So the mean, this is the actually the mean, will minus 5 by 5. So the mean will get subtracted by 1. So the median remains the same, the mean decreases. Option number C is our correct option. Is that clear? Is that clear?
Yes, sir.
This was an exercise of redundancy, not required. Great. Let's now talk about the third measure of central tendency, which is mode. First of all, mode for ungrouped data. Mode is what? The repetitive occurrence, the most repetitive occurrence of particular observation is defined as the mode. So in ungrouped data, let's say uh, 2, 3, 5, 5, 7, 5, 25, 125, 35, 2, 5. So these are the all observations I have listed in ungrouped manner. So which observation do you see is repeating itself most often? I can see 2 multiple times. I can also see 3 multiple times, 5 also multiple times. So how many times is 5 occurring itself? 1 and 2. Okay, 2 is repeating itself 2 number of times. How many number of times is 3 repeating itself? 3 is repeating itself no number of time. 5, 1, 2, 3, and then 4. 5 is repeating itself 4 number of times. 7 repeating itself, no. 5 repeating, no. 25 repeating itself, no. 125 repeating itself, no. 35 repeating itself, no. So the most number of repetitions is gained by 5. So the mode for this ungrouped data becomes 5 because 5 is repeated most often. Getting or occurring most often. Is this clear?
Yes, sir.
Let's now discuss about grouped data. So this time we'll not have to find out anything else. We don't have to find out anything else. We have class interval and frequency. That's enough for us. Let's first discuss the formula. Lower limit of the model class, and then the frequency of the model class and the frequency of the model of the class that is immediately above to the model class divided by the frequency of the model class minus the frequency of the class immediately above and the frequency of class that is immediately below into h. H is the class height, means the difference of lower limit and the upper limit. Okay. So L1 is lower class, should I write LL of model class, lower limit of model class. L2 becoming upper limit of model class. F1 being the frequency of model class, and F naught being the frequency of the class immediately above to the model class, and F2 is the model class, is the frequency of the class that is immediately below the model class. H is the class difference, upper limit minus lower limit. That is all. Let's now take an example. There's a class interval given and there's a frequency given. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Frequency given 2, 5, 7, 3, 2. Now, how do we find out, identify model class? Model class is the class having highest frequency. That is the model class. So which is the class having highest frequency? If there is any contradiction, though if there are two classes having same high frequency, then consider any one of them. Doesn't matter. So here, this is the class having the highest model, highest frequency, 7. Okay, this is the model class. So this becomes F1, this becomes F0, this becomes F2. Now, what is the lower limit of the model class? 20. Upper limit of the model class, 30. What is the frequency? It is 7, which we call it as F1, and F0 as 5, F2 as 3. What is the H? Class difference 0 to 10, 10, 10, 10, 30 minus 20, 10. Okay. So now the formula of mode, lower limit plus 2, sorry, F1 minus F0 upon 2 F1 minus F0 minus F2 into height. L1 is 20. F1 minus F0 is 5, 7 minus 5. 2F1, 14 minus 5 minus 10 into H, which is 10. So 20 plus 7 minus 5, 2. 14 minus 5, 9. 9 minus 10, minus of 1. Which should not be true. Which should not be true. Because we have done a mistake. F1 is 7, F0 is 5, and F3 is 3. F2 is 3. So 14 minus 5 minus 3. Why should I have written? I have written 10 here. So 14 minus 8, 6. 6, 6 into 10. 2 by 6, 3. 3, 3. This becomes 20 plus 10 by 3, which is actually 3.333. Answer is 23.3, which is our mode. 23.3, which is our mode. Clear? How have we identified model class? The class having highest frequency will be our model class. Okay. Then F0 will be just above, F2 will be just below. Remember the formula and it's very easy, cakewalk. Clear? Okay. So are you going to watch the India-Pakistan match today? Hello, are you listening to me? Frequency distribution. Yarini, is my voice audible?
Yes, sir.
So are you going to watch the match today?
India versus Pakistan.
Yes.
Maybe yes. If they allowed in my house, I was.
Okay. Do they generally allow?
I couldn't get you, sir.
Do they generally allow?
Yeah, sir, they do.
Okay. Try to conclude the class for 2:30. Who won the match, by the way? Who won the okay. So this time class interval is not given to us. Directly observations is given to us. है ना? Class interval is not given to us. Directly the observations are given to us. This is the question. So just tell me what is the mode? And remember the definition. What is the mode? You tell me mode, I'll tell you the result of toss. See, mode is the observation having highest number of occurrence. So here we have directly observation. We don't have any class interval. So 95 is occurring 4 times, 105 is occurring 2 times,
Related
115. Yes,
125, sir.
yes, very good. The mode is 125 here. Directly answer. Because we do not have any class interval. Direct observations are given. That is. Let's now move ahead and discuss the relationship between all these three. Between mean, mode, and median. So mode is equals to 3 times the median minus 2 times the mean. Simple. 3 times the median minus 2 times the mean. Okay? Clear?
Yes, sir.
Now we are going to discuss some of the most repeated previous year questions concepts. Okay. So first we are discussing curves. Curves of what? Frequency and class interval. Curves of frequency and class interval. So this is the axis of frequency and this is the axis of class interval. So if the curve is like simple parabola, bell shaped, no biases at all, like this, then this curve is known as the bell shaped curve. And when this curve is there, so mode, median, and mean are all equal because it is evenly spread. Why? Because it is evenly spread. Because it's evenly spread. Remember it. It's important. Bell-shaped curve. Next. Negatively skewed curve. Next comes negatively skewed curve. Who won the toss? Do you know?
No, I didn't see the clip, sir.
Very good. So in negatively skewed curve, what happens? The curve is a little bit ahead. Like this time, the majority portion, like the slope behind is somewhat more, how should I put it? Less inclined, and then the fall is very steeply declining. And this time, the relation between mode will be greater than median, and median will be greater than mean. And if you are trying to understand it, please don't try. This is just a curve topic. remember the curve and the relation. That is what you are supposed to do. This is negatively skewed curve. Now let's take an example of positively skewed curve. This time the curve will be spread in the initial part. And mode will be less than median, median will be less than mean. Simple. These are three curves. Bell-shaped curve and mode, median, mean, all are equal. Negatively skewed curve, when mode is greater than median, median is greater than mean. Positively skewed curve, when mode is less than median and median is less than mean. Three curves. Clear? Understood? Understood?
Yes, sir.
Okay. Next comes representation of data using different charts. So first comes the bar chart. There will be bars. Um, let's say this is the bar. Let's say this axis is telling us the frequency. This is telling about the different categories. Let's say uh, we are discussing about the sales of cars, sales of auto rickshaws, sales of bikes, and buses. And this is the frequency. Like, let's say this is 100, this is 120, 80 cars were sold, and 40 bikes were sold. So this is how bar chart represents data. So cars, autos, bikes, and buses can be represented like this also, where number of cars sold is 100, autos sold 80, bikes 40, buses 120. This is how we can represent this data. Clear?
Yes, sir.
Okay. Let's represent the same data using a pie chart. Using a pie chart. And there has been multiple questions from pie chart in previous year paper. So in this, we'll take a circle, and the area of circle is also depending upon the total rate, total A, total like observations. So first point, area of circle is proportionate to total observations. Yeah, फिर I should write sigma or fi. Sigma of fi. Now, this time. So total is, what is total here? Sigma of Fi. 180, 40, 220, 220 and 120. 220 and 120 is 340. 80, 40, 120, 240, 240 and 100, 340. Okay. Now, the total degrees that are there are 360 degrees. Okay. Out of 340, 100 is for the car. So for the car, the ratio of cars upon total is 340. So in this ratio, we are going to divide its theta by 360. So the angle occupied here for the cars will be 3 theta into 100 into 360 divided by 340. 0, 0 cancel, 17, 18, 1800 upon 17, which is about 100. Let me use the calculator firstly. So 105 degrees. So if I'm like taking this, then about 105 degrees is obtuse. So this is for cars. This section is for cars. 105 degrees. Then talking about auto. So 80 by 340, this is the ratio of autos to the total into 360. 0, 0 cancels. And this becomes 360 into 8 divided by 34 as 84.7 degrees. 84.7 degrees. So let me dedicate 84.7 degrees will be somewhat like this. 85 degrees, let me say. And this is for autos. So this is how pie chart is formed. For bikes, 40 upon 340 into 360. So about 0, 0 cancel. 360 into 4 divided by 34 is 42 degrees. So 42 degrees angle will be taken. So 42 degrees is somewhat this. 42 for bikes. And this is remaining 120 degree for buses. And the whole 360 degrees depicts 340 total number of vehicles sold. Okay, so this is how we can use the pie chart. The important thing to understand is the area of circle depends on the total number of observation. It is proportional, and the center angle will be found it out by the ratio of let's say of the object to the total. Basically, percentage. We'll find out the percentage and we'll multiply it by 360. This is how we can find out the central angle. Clear everything about pie chart?
Yes, sir.
Next comes histogram. Histogram, same. There's a graph between frequency and class interval. It will be bars like this. Okay. There will be bars, but the bars this time will be interconnected. So the next bar is like this. of same width, of course. Like this, the data will be represented, and this is representing class interval. This is representing frequency this time. So if you make a dot here, here, and here, and if you connect all these dots, then it will form a frequency polygon. Hear me out. It will form a frequency polygon. Form a frequency polygon. This is known as the frequency polygon. Very important previous year question. Okay, this is all what you need to know about histogram. It's a graph between frequency and class interval. Okay.
Yes, sir.
Let's now talk about OGIF. So OGIF is the graph between cumulative frequency and the class interval. What? Cumulative frequency and the class interval. This question is also asked. The graph of CF and CR. This time there will be two curves. This is a curve of less than OGIF, and this another curve is of more than OGIF. What do you have to remember? The intersection of both of these is the median. This is the median. This tuck, 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 tuck. This is the median. Clear? Is this concept clear that more than OGIF, less than OGIF intersection is median, and the OGIF's graph is CF versus CI? There's two things to remember. Clear?
Yes, sir.
Let's take an example. In a test of maths, 20% of students obtain first class. If the data represented by chart, by pie chart, then what is the central angle that we need to find out? So 20% into 360, 100, 0, 0 cancels, 0, 0 cancels, 72 degrees is the answer. Clear?
Yes, sir.
Yes. What is left is mean deviation, standard deviation, variance, and the correlation regression topic. And particularly from the correlations and regression, there is a lot of questions asked in statistics portion. We'll cover that in the next class. Okay. Any doubts?
No, sir.
Okay. Thank you.
Thank you.